Good morning, all.
Recording is on.
Welcome, everyone. We'll be getting started pretty soon. Give people a few minutes to show up here.
Recording is on.
So Jeffrey, did you know that the link in the invite actually points to a Google Meet, even though it says Blue Jeans?
You're kidding.
Oh, I clicked on it
No.
like 3 or 4 times, and I'm like, nobody's letting me into the meeting. I'm
Huh.
feeling rejected and depressed, and a hit to my self-esteem, and then I looked and I realized I was in a Google Meet.
Oh,
And
good Lord.
Yeah,
I don't even know.
hijacked it.
I don't even know how that's possible. I mean, I'm looking at
well, I
the.
was I was weirded out about it myself, and I finally cut and paste the text for the hyperlink and dropped it in and got to Blue Jeans. So
Same.
Huh.
If
Well,
you
I
look
wish
at the Google link, there's this big long thing that has a Google Meet.
By
I tell
golly.
you, they're hijacking our links now.
that's right, man. It's a plot.
They always have.
I
Google
don't
as
even.
always has ejected your link.
I followed that
I'm
link. I
trying
got
to.
in just fine.
I don't know what happened. I mean, seriously, I clicked on it twice and
Google
ended
does
up.
not like you, Clark.
Yeah. It
It's
was
just
like.
me.
I
It's
see that.
No,
if
it
you
was.
ever,
What happened to me?
It
it's
was
called
like me either.
pepcac. It's
I'm
problem
sorry, Bruce.
exists between keyboard and chair.
No problem. The problem is it was in the meeting invite. I just checked it.
Is what we're talking about here the fact that Google surreptitiously wraps URLs such that they look like a public URL, but then when you copy them,
Yeah,
they are a Google redirect so that Google knows that you've clicked it.
that may have been what happened,
Maybe.
but for
Yeah.
some reason, what happened to me, Ian, was that it dropped me into a Google Meet.
Yeah. No, I
Oh, that's
I,
okay.
I just looked at it, and that was absolutely the case. So I have fixed it in the invite for anybody else who's coming in. But my apologies.
So what
Oh, should
what
we
you're
go
saying
back?
is
I've been
Should we have
defeated by
Clark?
Google.
Should we have
Is-
Clark go back to that Google Meet briefly and invite anyone who's sitting there?
You
you just
Nobody
want me
get
to
in.
go back there.
Where the party's at?
I already said this was damaging to my self-esteem that I was sitting in the meeting and no one was letting me in.
Yeah.
And I felt rejected and belittled, and just in general, my self-worth was hurt. So,
Is this the Google equivalent of Clippy?
oh,
It looks
could
like
be.
you're trying to join a
It's
Google Meet.
sounds like you'd like to go to an Android Automotive
I
meeting.
like that. Yeah.
Right.
No, I wouldn't.
No, that's not what I want to do.
Oh man.
If I could be conspiratorial for a second, Google probably figured out, they may be using the Google authentication for the Blue Jeans. So let's click through, see if it works, and then we'll pipe it through Meet and then wean them off of Blue Jeans, and they'll just use our product.
First, let me state that I'm just shocked that you're going to be I can't believe it. Shatters my faith in humanity. But yeah, I can
Can I
see that
point
happening.
out? Can I point out though that Bruce has the perfect office setup for being conspiratorial for a second?
Well, good point.
This is my lair on the dark web. Oh, nice graphics. By the way, I mentioned to a client that I do research with yesterday that the recipe had dropped to the public repo, and they were all excited.
That is going to be our big news coming up here in just a second.
And the email to the Automotive SIG list, it doesn't. Well, I guess I know what I'm gonna do after that meeting.
So, well, speaking of which, let's go ahead and get moving here because it is getting late. So, welcome to the CentOS Automotive SIG meeting for October. This is the formal meeting. As everybody probably knows by now, we have 2 meetings a month. There's a formal meeting and there's an informal office hours. As we will see when we go through, we're going to be switching the times up on these meetings a little bit because I did a poll, and I want to thank everybody who responded to the poll. We had 20 responses, and we'll get to that in a few minutes. But we need to sort things out so that more people can come to the meeting and be in the loop. So we have some actions from the previous meeting we can go over. we have an update on the build and test infrastructure. We have talked about the future meeting schedule and a request for help to develop contribution guidelines. As we get further along with developing the build and test infrastructure, that means that we have code and we want to make sure that everybody. So there will be some people I will be roping in to draft some contribution guidelines, but if this is a process you'd like to be involved with, we would like to know. And then we'll have some open discussion. I apologize, I may need to leave a little bit early, but Ian will be taking over and the recording will continue. We should be all set. So I left the introductory slides in just in case anybody who sees these slides or this video later wants to take a look at them. I'm trying to, I can't really tell from the people, it looks like there's 19 people here, it looks like. Most of the names look pretty familiar. Would anybody like me to go through a quick overview of the SIG, or are we all pretty much in the loop on everything? Or go ahead and you can, I guess, raise your hand if you'd like me to do a couple of minutes of introduction to the SIG, or should we just dive into the technical update? Don't see any hands going up at the moment. You can always ping me later as well. Ping me offline. I'd be happy to walk through the SIG with you. General goals and the specific goals that we're still working on. Next week, the next meeting, we should probably do an update on these to make sure that we know where we are and how close we are to meeting them. The actions from last meeting, one was to continue developing the basic build and test infrastructure, and I think we'll have some news on that in a moment. Find a better time to meet, which is also on the agenda today, and to encourage all interested parties to join this community. And that one was actually a kind of a call to action for everyone, that if you have run across people who are interested in developing open source automotive software in a distro context, this is hopefully the place to bring them. If you would like some help reaching out, some slides, or any community management activities, feel free to ping me directly. I'm Jeffro at Red Hat. My address is probably on throughout the mailing list and everywhere else, and I'd be happy to jump in. So let's dive into the real interesting part of the meeting, which is going to be the build and test infrastructure. I believe we actually have a code base now. Here, are you on? Do you want to take a whack at that?
I am here.
Excellent.
We indeed have a project now that is. So based on the discussion we had in the last meeting and the discussion we had on the mailing list, we ended up picking GitLab as the place to host our code. It is currently under the Red Hat namespace, which means we can only have people from Red Hat having commit access to the code. Anybody can contribute via merge request, but only people from Red Hat can actually have commit access. But this is hopefully temporarily, at least we want it to be temporarily. And the idea is to move this to the CentOS namespace as soon as that namespace becomes available. I have put in the chat here the link to the place. So it is gitlab.com/redhat/automotive/automotive SIG. It means we have the entire Red Hat automotive namespace in GitLab. So if we ever wanted to host other projects there, it's going to be very easy to add other projects next to this one and then move them along as we want or need to. All of them could of course be migrated to the CentOS namespace as soon as that one is available. What we currently have in there is we have OS build manifest. So there are recipes that OS build uses to build images, and we have manifests that can be used to build QCOW2 images to run on libvirt or QEMU directly, as well as OS build manifest to build images for the Raspberry Pi 4. If you have an ARM, so one of the requirements is that you can only build ARM64 image on an ARM64 server or machine, and you can only build x86-64 images on x86-64 machines. So if you have a running Raspberry Pi system, that's running, be that Fedora, CentOS, RHEL. If you have one of these systems running, you can get OS build and you can create a CentOS stream-based, OS3-based Raspberry Pi 4 image with Neptune, which is our demo app. You can do the same. You can do the same thing for QEMU, and then something like Git Manager and connect to the Raspberry Pi to get the image running. It's a little bit nicer than running libvirt directly on the machine. Running libvirt Manager directly on the Raspberry Pi. What else can I say on this one? It's currently CentOS Stream 8 only. We are going to be looking at CentOS Stream 9 shortly. You have documentations as well in the Git repo, but you can see the source of the documentation in the docs folder here in the Git repo. But you can also directly access it under sigs.centos.org/ the link in the chat here. It's also in the README. And that documentation also includes all the instructions on how to build these images. You even have the instruction of, if you don't have a Raspberry Pi system, how to get a CentOS Stream Raspberry Pi system using the CentOS Linux 8 image and then upgrade it to CentOS Stream 8. And then which you can then use to build images. You can see that there is a page that says downloading images. This is currently a placeholder. We're working with a team at Red Hat that is looking at providing a CI kind of CI pipeline for this repository. The idea is that every time we open a merge request, that is going to trigger the pipeline that is going to build the image, test that it works, and let us know how it did. In a similar way, you will see in the Git repository here a folder named package list, and that's which contains two text files, one for CentOS Stream 8, the other for CentOS Stream 9. And basically, the idea is that every time CentOS Stream changes, they have a service that's going to open a merge request to this project. And by opening a merge request, again, we trigger the pipeline, which means every time CentOS Stream changes, we have a rebuild of our images and a test that they still work. So if CentOS Stream was to, for example, rebuild Qt, which would then mean for us that we need to rebuild Neptune, we should know about this in the merge request here. So this is work in progress. Hopefully, will be live soon. We'll have definite ATA there, and it's definitely close. You can already see we have a few merge requests open. You can already see that the pipeline is being triggered and reporting. It's just not successful yet. The idea is also that we are likely not going to provide images per se. The images will be available based on what the CI pipeline builds. Be able to directly download the Raspberry Pi images and flash them onto an SD card and put them, simply because the CI pipeline will build these images as well. I think I've covered most of what's in there and to be that I had in mind. If there are any questions, I'm of course happy to follow up. Otherwise, Jeffrey, to you.
Okay, thank you. Any questions from the group? Go ahead.
Yeah, I've got one. Is there a relationship, or could you elaborate the connection to CentOS project namespace in GitLab, i.e. what I just pasted there, just to elucidate the group on the relationship?
Yeah, we want to migrate our projects to the CentOS namespace on GitLab. The issue is that the CentOS namespace currently does not use the CentOS authentication system, which means you could be Bruce on GitLab and not Bruce on CentOS, and that is perceived by the CentOS project as something that they want to solve. That a direct relationship between if I'm adding you on the CentOS management system to the Automotive SIG, that the group can be then propagated to GitLab, and that your username on GitLab is linked to your username on the CentOS account system. if you have experience, please set up on the Red Hat namespace. They basically want to offer the same experience so that the group management is not done on GitLab, but it's done in the account system. And the GitLab account system is linked to the CentOS account system. And this is currently work in progress. It's being discussed with GitLab. It wasn't there yet for us to benefit from. But the idea is that as soon as we move to, as soon as it is available, then we can migrate to the CentOS namespace. And at that point, anyone with a CentOS account can be added to the right groups and get commit projects.
Thank you.
I wanted to highlight something that I don't think I'd appreciated about the namespacing that you mentioned. To reiterate, this is us sort of stepping in as, from a Red Hat perspective, as one of the early participants in the SIG and demonstrating something for it. And you've put it, I guess we've grabbed the automotive-SIG project name underneath that, but this by no means limits the scope of other things that people might do or contribute to. This is our initial involvement, which I'm grateful for. This looks great. I'm really excited that this is up and visible. So thank you.
Totally agree. Yeah, this is really exciting. This is kind of our stake in the ground. So, any other questions? I know that Pierre was very thorough in describing everything. One thing I would add is that the manifest that is here and the code that is here is a starting point. It is not intended to be the delivery of a final product. The whole goal for the SIG is for us to be able to work on these things collaboratively. So feel free to dive into the manifest and take the manifests and take a look and see what you think should change. It's all very well laid out, and I'm really glad the infrastructure is coming along so well. So do we have any other questions about the infrastructure? I know there's probably very interested in this portion of it.
This is Philip talking. Can you hear me?
Yes.
So I have a question that is loosely coupled at least to infrastructure, which is, what is the vision of the SIG to help people first developing their own board support package? Because we know we're not going to run a Raspberry Pi in a car. Mm-hmm. The second thing is, how are we going to deal with people who don't have native ARM machine to do the build, which is probably 99% of the population?
I will say half seriously that the answer to question 2 is to buy them a Raspberry Pi.
Yeah, but you're not going to go in a car with a Raspberry Pi.
No, this is true, but it at least allows you a native 64-bit ARM build environment. As to how, go ahead.
It's not fast enough. Sorry. It's not fast enough.
I just wanted to point out that one of the just as a, I mean, the CI pipeline and the fact that it reacts on merge request, although very far from ideal, would actually allow someone to contribute and have whether their merge request builds on AR64.
Sorry, did we lose? Yeah. Okay. So I think Pierre was saying that the fact that GitLab has infrastructure to do these builds and that it reacts on merge requests means that the builds can be done through GitLab. And that isn't obviously ideal. It'd be ideal to be able to do a local build, but there is still a possibility for building and then doing a local test.
I do have some experimental work that lets you build ARM stuff in a VM, like not a KVM VM, but a software VM where you emulate ARM on Intel, and it's not the fastest thing ever, but it works.
It might be a good thing. Go ahead.
I want to focus back in on the BSP question because I think it's a really useful one, given that the broader community here is clearly very familiar with this concept and using these things called the BSP, which from a CentOS perspective is not unheard of either. At least the activities involved in a BSP. And when I map that to what I'm more familiar with from Fedora or CentOS or RHEL, essentially is very often providing at a bare minimum additional kernel content or a complete replacement kernel and some additional user space packages normally that are designed to interact with that additional kernel content or that replacement kernel. And when I say it's not unheard of in the CentOS SIG space, the one that I'm aware of anyway is the Zen SIG, where they actually produce an alternative kernel, albeit one that is more closely related to the mainline CentOS kernel. So I think it's clear to me from past experience with, at least in the 32-bit ARM space in Fedora, that we never had a great way of sort of being open to this concept of a BSP and finding a way to make it possible to use something like a BSP in conjunction with an RPM-based distribution like Fedora or CentOS. And I think that's an issue. And I know, Stefan, that you and your entity have put a great deal of effort into creating an environment where you can do this and also where you can do cross-compilation, which are not things that we've attempted to bite off or work with or fix in the CentOS build environment just now. So is that, first of all, am I speaking generally to the areas of your interest?
At least on our side, yes, clearly that's you're addressing the right issue, which is how we can address the diversity of boards. Because even if we support 10 or 20 boards as a reference board, it's not going to be enough. Okay? We will always have other boards going on project. So we need to have a mechanism to create that abstraction. Yeah.
I mean, ideally, work should be going upstream, land in the CentOS kernel, and then we just have it. Alternatively, they could be directly in our automotive kernel, but maybe we should, for like the shorter term, have a way to build at least kernel modules as RPMs and have them like auto rebuild whenever the auto kernel is updated or something like that.
Yeah, I agree with your definition of the ideal, Alex, and I'll also repeat that holding tight to that ideal meant in the past that Fedora wasn't a very active area of development for these types of hardware. So I think an interesting area for the SIG to focus on is how, if this is a CentOS SIG, and it is, how do we adapt the idea of a BSP to something that wants to be built primarily using CentOS-derived packages. And as I said, I think the early model for that is the Zen SIG, where they do provide an alternative kernel. And in fact, they provide some user space components that aren't otherwise part of CentOS proper, and that wouldn't be in the stream. I think that's worth doing. I know I've done this on an ad hoc basis in the past. It would be nice to have a more standardized way of doing it. And I would say the goal then would be, would it be possible for someone to do what we did? I think we actually proofed this out, Alex, earlier on in the program, where we said, although it is possible to run a Raspberry Pi on proper CentOS, what if we pretended that it wasn't, and we used a Raspberry Pi BSP as the hardware bring-up mechanism? Like, I think that's the use case being described here, where there's a working bootable kernel. Probably it has been described as a Yocto recipe rather than as a spec file, but we'd like it to be possible to run that hardware with the sample user space, for example, that Pierre just presented earlier. So acknowledging that that's a useful thing to do, coming up with some techniques to do it, and providing even some infrastructure for it in the SIG, maybe that's worth doing. Maybe that's worth highlighting.
I mean, so one of the main problems with BSP is that they're talked about as if they were a very specific thing, but they can actually do whatever. Like it can step deep into the tentacles of building glibc and tweak some things. And it
Right.
might be
There would,
interesting to get a list of all the existing BSPs and see what kind of things are generally done by people who are like knowledgeable in BSP layers.
Stefan
That would
speaking here. I think you you can get to be honest, it's a jungle. You can get anything from a, let's say, clean BSP with a kernel trying to follow the upstream, and something trappy, very old, with strange drivers and firmware. So don't expect anything to be normalized on here. Um, I would add a small comment regarding what you call BSP. Keep in mind that it's not only the kernel. Of course, the kernel is essential, but you have usually a lot of patches on top of it. You may have a very specific kernel which is not vanilla at all. Okay, so even if vendors try, I mean, SOC vendors try to push their patches to kernel.org, usually they still have to have their own patches for their SOC. So you get a bunch of patches on top of your kernel. And beside of that, you have to also support some kind of user space libraries to support GPU or other accelerations for various things like multimedia, audio, or whatever. And usually it's not part of the standard design of Linux as you can see on the desktop or in Fedora. So it's more complicated than just the kernel. That's what I mean.
Yeah,
Yeah,
but
usually
I mean, and that was actually what I meant. Like, it would be interesting to have a list of things that are typical in BSPs, and then we can find extension points or whatever in our distro where we can have a standard way to hook into like these common things.
Yeah.
When I hear BSP, that generally implies that you have a kernel and rootfs tailored to a particular target, like, some board. And one of the things we are trying to do, we being Red Hat, are trying to abstract that through either device tree or ACPI tables so that we can build an architecture kernel and not a kernel compiled for a particular target, but just a kernel built for ARch64 that then gets the definition of the hardware from that device description and loads the appropriate modules. It's going to be a long road to go down that path because everybody is very used to using the BSP/Yocto model and building something strictly for a particular target. But
I think everyone agrees that on the very long run, your vision is right. The question is how we move to that long-term vision. And as Stefan said, here we have boards where we have 500 patch to apply before even being able to recompile the kernel. This being said, the today world on BSP is far from being perfect, so we don't have to reach perfection, but we should have a solution. Okay, yeah. And if we don't have a solution, then people clearly cannot adopt the system. And the first issue is effectively how we separate the low-level stack, okay, because that's the kernel plus how you boot plus few other things, from the user land world where we want to use standard packages. And I think we need to have a story and we need to have a roadmap for people to move from one model to the other one. Today, effectively, as it was said, there is no real model. Okay, in-house here, what we do typically is we take a BSP and we start doing a huge cleanup. That's the first work. Okay, as you said, the BSP typically is far too big. So the first thing you want is to minimize it. This being said, when it is minimized, and we should have I don't say 100% automatic model to move to the standard build system, but something that is relatively automatic and standard, yeah, which we don't have today.
Well, the hope would be that we could eventually have a basic root file system. And there might have to be variants, you can start all kinds of nasty discussions talking about System 5 init versus System D is how you do init and come up from there. So I could see us having a couple of variants based on what people need. But it seems like we could start with 2 or 3 basic rootfs's that get you up to the point of starting services, and then let people tailor those as they go forward to say, okay, well, I need pin control drivers, and I need this particular interface card, these wireless chips, this Bluetooth. Cause all that to get loaded and set up. I came from the embedded world about 15 years ago, and it was just a complete pain to generate rootfs's, and we were always doing it from source. It seems like if you can find an entity you can trust, like CentOS Automotive SIG, and can pull packages from there, that at least removes part of the pain of setting up a embedded system that we're talking about here. So, if we can, I know there are some efforts in place for having tools that will compose a root file system for you, so that you can say, I need this basic set of recipes, and then I need these particular packages, like maybe the C++. Shoot, I can't remember the library, the numeric libraries that they are, but point at some particular special purpose packages and say, build me a rootfs image that would be suitable for me to slap into a flash partition. I don't know if those are areas that we feel like are profitable for the CentOS SIG.
I want to ask a question, because my impression, I'll admit, Alex and I both dipped our toe. I dipped my toe, and Alex stayed in the Yocto and AGL space for quite a long time. But my impression is that it's not a BSP very often still makes use of most of the user space that comes with either Yocto or AGL. And that, in fact, what the strength of Yocto and BitBake is that it's the same tool set owns both the kernel compile and everything onward to image generation, and potentially even getting the image onto the device. So you can provide essentially a single artifact as a layer, and we tend to call this type of layer a BSP, that is the kernel, some user space, but by no means not like a canned, completed rootfs, and the instructions about how to structure the image so that it works for the device. And all of those things can be delivered in one location. So beyond the other problem with applying that approach to Fedora or CentOS, which is that we have a kernel and we want it to be derived from upstream. The other challenge, an additional challenge with the BSP is, even if you did have it upstreamed, or even if we did work out a way to bring in alternative kernels and additional user space components, that there's usually a little bit more, often in the image building, which for us is a completely different set of tooling. So whereas the root, coming with a already prepared rootfs is not as common, but I could be wrong. I know there are other people who have seen more Yocto and more AGL BSPs, but.
Stefan here. I would say that, in fact, even Yocto the imager is far from perfect. Currently, what we see that Anaconda is not the right tool from our experience to build the target images. In fact, you can build your images, but you have to run your QEMU to emulate the whole thing, because some post-install steps require some daemons running typically, and so you can only emulate that. It's very difficult to create. Let's say that Anaconda is a tool where you can create a live image, okay, or an installation image for your distribution. We know that it's perfectly fitted for desktops.
Mm-hmm. Yeah.
But from our experience, what we see with embedded world is that ideally you would like to deliver a boot image which you just flash on your board and you boot. And in a magic world, you would even do nothing in the first boot. And we know that Yocto
Mhm.
has to do some tricks at the first boot because
Yeah.
only a few things can be done at runtime at first boot. Typically provisioning, some security stuff, or in fact you have to run at the first boot what you can't run on your QEMU basically. And so that's a real challenge right now. And there are not many tools who can address that issue. We are working on some ideas, but nothing perfect here. So if we can design something on the imaging side on the CentOS Automotive SIG, I think it could make sense and solve many problems in the automotive world and also in the embedded world more generally.
Yes, I didn't mean to suggest that Yocto had completely solved that problem in the general case, but at least it provides a clear mechanism. If you need a customized solution for a particular hardware platform, it's very clear where to put it. You have to take over that stage of the build sequence. You have to write a recipe, and BitBake will execute it for you. But yeah, everything else you said makes sense to me. I'm intimately familiar with the challenge of taking a OS that was primarily installed by an on-hardware installer and then turning it into something that, because we encountered the same challenge when creating images for use in a cloud environment where there is no installation step. There's an image and it gets launched and it doesn't want to do something when it starts up. So
yeah, many similarities here. In fact, I think that the strength of Yocto is that you can it's how you can compose some fragments to express different things, whether it's recipes where you can add a few things, a few changes. I'm not talking about patches, but it's a bit like if you had multiple fragments to compose a spec file, basically coming from various locations. They just call those locations layers, right? But
yeah,
that's the idea. And at the end, so you compose your recipes from multiple locations, and you try to expect that everything is harmoniously built. But one limitation of that is that at some point, if you add a new layer that maybe happens something wrong, then everything gets wrong. So the complexity is that at some point you are unable to manage how things are built. Even for the kernel, you compose the config fragments for your kernel, but at the end, unless you look at the result file, you are not able to define clearly how your kernel is composed. So that's a limitation of things. So if you are doing demos, if you want to grab some adoption for your project, it's easier. But at the end, if you want to make a product, I'm not sure that's the right way to do things.
Yeah, no, I get it. I really appreciated a great deal the sort of easier composability and flexibility of Yocto, but as you point out, it is more brittle to change as a result. So let me try and zoom it back out. The original question is, what do we do for people who want to develop BSPs for CentOS? Then we had a lengthy discussion where I think the assembled expertise here agree that there's no single answer to that. And I wonder if the question is, if there's really two questions here. One is, what do we do for a platform that already has a BSP? And there the answer is, well, it's going to differ on a case-by-case basis because there's very little commonality. There's no standardization of what this concept means. But the other more interesting question is, how do we come up with something comparable for those who want to join the automotive SIG? And this might even apply more broadly to Edge, that is a little less doctrarian than the current answer, which is as soon as your platform runs on the upstream kernel and can be imaged using our standard image tools, it will be supported. And until then, you're essentially on your own, which is very different from the experience of trying to integrate with Yocto or AGL. And it's not going to be, the answer won't be the same as writing a BSP. We're not going to say, write a BitBake recipe for your kernel, and if you need to override or extend the BitBake recipes for flash imaging, it's going to be different than that. It's going to be, add these patches to the RPM for the kernel, or if necessary, create your own kernel RPM, but make sure that it provides the same, satisfies the same dependencies as the one in there. add your user space components as packages and then augment or plug into the image building tooling in this way. Does that sound like it's essentially what is the CentOS equivalent of developing a BSP, and how can we make that a little friendlier than it is right now? Does that sound like a worthy problem to start to chip away at?
At least on my side, yes, it is. It is the right answer. We have a population that use Yocto, and they like it typically for most of them.
Mm-hmm.
And so we need to provide them an acceptable way of adoption to migrate to the new model, or they're not going to migrate.
Makes sense.
This being said, I think there are also other elements we should look at, because if we focus on the requirement of today or yesterday, honestly, our chance to be successful is not that big. But if we incorporate the new requirements that are popping up, and I'm especially thinking to the cybersecurity requirement with the new standard ISO 26662, which is going to be mandatory for any new model after 2023 and any new car after 2025, even if they delay by 1 year. It's a big issue for the manufacturer today. So container is another part where they also have some significant issue. Boot time is also something we could talk about. But if we address, also those issues, okay, then it provides another added value for people to change. And for example, in the new cybersecurity spec, it is enforced that you can trace any assets that you include in the system with the notation of its cybersecurity risk, its dependency, and what is going to happen if this asset is compromised. Okay, and to be honest, Yocto is not the right tool to trace all those dependencies. So I think we should also try to understand what we could leverage from the package infrastructures that help us to address those needs.
In terms of bringing this to a call to action, do you think that it would be wise to encapsulate this in a porting guide? I mean, it seems to me that the goal for a BSP is to port to a new piece of hardware. Maybe these are these porting issues, or do you think it's more of a wider scope?
I'm not sure to understand your question. Sorry, I'm French, and so my English is not that
Sorry.
good.
I think the question is how do we take the ideas here and address them in a way that they can be publicly consumed? Where should we capture this information? We have a code base and we have a wiki. I think this is it. I would like to keep this discussion going beyond the scope of this meeting.
Yeah, I like where you're going, Jeffro. That we want to.
I think a wiki is not a bad idea, or a portal. Yeah, I don't know, whatever you have. Yeah.
Okay.
But let me throw out two straw men. One would be, I think, what you were alluding to, Jeffro, which is we start to write this up in the abstract as a set of guidelines. The other, which I tend to favor, is let's just pick a few platforms or solicit people to come with platforms and do this. We did it with sort of did it with Raspberry Pi as a synthetic exercise, but if there are other platforms that are well supported under Yocto or AGL via the BSP model, but that aren't bootable via Fedora or CentOS, chip away at a few and use that. And I think both of those could go on in parallel. And one key insight from people who have a lot of experience with this on this call is that there's no one approach that will work for every BSP because the definition is so loose. But hopefully there's enough commonality that we could start to build up some sort of general guiding principles for how to do it.
Okay. I was a technical writer for a long time before I got into
Bless you.
management. So I tend to think of solving problems with documentation first.
You're
So it seems to me that a good place to capture this would be in a porting guide. So this exercise of bringing in new platforms, if the goal is to port the CentOS automotive distribution to new platforms, so we can capture that in documentation.
The problem we're going to have, negative person, but one of the obstacles I see here is there's this big disparity of performance on platforms. A Raspberry Pi is very affordable, but not very fast. A Qualcomm Snapdragon, is an 8-core beast with all kinds of peripherals hung off of it, but it's incredibly expensive. Not going to be something most people will write a check for. And leaving aside for the moment that we do have a chip shortage, and they're hard. That sort of thing is hard to get these days anyway. So I think one of the things we ought to look at is where do we want to focus? I'm not sure that the CentOS Automotive SIG can do a lot of performance-oriented work just due to the fact that it's going to be hard for this organization to acquire that sort of hardware. It may be possible. I'm not ruling it out. And if we could get, a half dozen or so high-end Devel platforms and could figure out a place to put them in a lab so that they could be remotely accessible, that'd be fantastic. But I wonder at the fees. I'm seeing things like I just bought this, which is an Asus platform called the Tinker R, and it's a big little ARM core thing that's got it's a Cortex 72 and some other, but it's probably on the order of a Raspberry Pi 4, maybe a little beefier, but certainly not anything that you would want to say, hey, let's base the U around. And that's what I think we're going to have to deal with. The fact that our platforms just are not going to be completely suitable for using as an ECU.
Do you mean during development or even like when deployed?
What do you mean? I missed
Like,
you.
are they slow to compile, or do you think they won't even be able to run?
Well, some of the platforms we're looking at feed 8 or 10 video streams into one ECU. And
we're not going to do that, but are we?
Right.
Do we have to do that on our testing platforms?
No, we don't. But scalability can be an issue. You can write something that's really great. It takes 2 video streams, and then you throw 12 at it, and it goes or falls over.
Yeah.
So I guess I think that was the concern. I think it was Philip brought it up, was that a Raspberry Pi is not really suitable for the high end of this and prototyping a complete ECU. But the fact is that a Raspberry Pi or one of these little single board computers that is ARM based, the structure of what has to go on them, make them do something, is very similar to what we have to do. It just scales up and becomes a bit more performance oriented. So, I got one of these, a little Pi Racer that's got a Raspberry Pi 4 on it, and don't ask me to make it move because I haven't even installed an OS on it yet. I just got the stupid thing put together. But the structure of what we're talking about here is a set of firmware kernel that enables the underlying devices, and then a user space that makes use of that. We can do a hell of a lot of prototyping, a lot of frameworking on these little guys that hopefully would then scale up.
Yeah, and hopefully time will also solve this issue.
Yeah.
Like ARM boards will be cheaper and more high performance. More people have MacBooks that are ARM maybe. And
somebody will eventually figure out how to port Linux to the M1.
Yeah. Well, it's kind of sort of working, I believe.
Yeah. Our friend John Masters will design a new set of ARM chips over there for Google that will become mass market, and we'll all have.
Well, that's actually not a weird idea. Could we support some kind of slightly older Android phone as a target?
Huh. I don't know.
Those are pretty quick.
I'm not giving up my Pixel 3, dude. Sorry. It's not going in a board farm just yet unless you give me a Pixel 6.
I know there's a Pine phone. Is there a Pine tablet?
There's a Pine laptop.
Yeah,
and
the Pine book, yeah.
Yeah.
I've got one over here, but
those things already boot. You know, they have the kernel porting and other things are generally solved.
Yeah, but I don't think
what
they're.
we're talking about here is even those very open friendly platforms do not run CentOS or Fedora right now.
It's Pinebook.
But this being said, there is a big difference whether we target two guys in a garage, in which case Raspberry Pi is effectively fine, or whether we are targeting Panasonic or Denso developers when they do a proof of concept. Okay, and if we want to be in a car one day, we should target the Denso and Panasonic, advanced research and so on. And for those people, if we want them to feel close enough of what they do, I think there are a few things we should support. We should support clearly one Renesas board, okay, because typically they have a Renesas M3 on their desk. We should support one NXP8. We don't have to support all of them, but we should take one of them. We should support one NVIDIA and one Qualcomm, because at least if you do that, you somehow cover more or less, what those people understand. You speak the same language. And I agree, we should also support Raspberry 4 for, people in their garage, or even for, if you give a training and you want to buy 20 board and give it. So, but in between supporting everything and supporting only one, you have a trade-off.
Mm-hmm.
Part of it is actually getting access to that hardware, and if we have contacts with some of the manufacturers of these developer boards, do we think we could work some sort of deal where we get remote access to them? Would they open up? Would they punch a hole in the firewall and say, "Look, here's an SSH port to one or two boxes that are dedicated to use by CentOS SIG." CentOS
At least
Automotive.
in our side, we never had remote access, but we've been given boards by many vendors.
Yeah, that's my experience as well. You're more likely to get.
Well, the problem is that they're not very friendly to the idea of being controlled remotely. When you start having to flip a dip switch to reprogram flash, that becomes problematic if the data center is 3,000 miles away and it's right.
Yeah, but I think getting few boards from vendors is normally not that complex. Okay, I don't say it is simple. For example, with Renesas, it is very complex. But NXP, for example, probably is easier.
Jeffro, do you think there's the possibility that we could get some rack space somewhere if we could get 4 or 5 example boards of relatively high end? Could we then put them?
Yeah, I think that we actually in the first meeting, I believe we touched on the possibility of a remote board farm.
Yeah.
And it certainly is an issue that keeps coming up in conferences. I think other people.
Well, I mean, it's the problem is that we have a scarce resource. It's expensive, hard to get a hold of, long lead times. So if we can figure out a way to pull them into a shared environment and make it so it's usable for people to say, log into some infrastructure and say, build me a use this recipe to build me a root file system and a kernel that boots on this particular platform and install it. That's the ideal.
Is it doable though? I mean, you can hook up a terminal or something to a serial port, but the actual flashing, how's that? Is that remotable?
It depends on how it's organized, but in many cases you can actually do the flashing from Linux. Then of course you have to reboot and hope that your firmware has the right, the ability to say, oh, what we just flashed sucks. Let's go from that B partition back to the A partition and boot from there and recover. So it's chancy, no question.
The groups that we've
I want to be cognizant of time. Sorry, I don't mean to cut anybody off. We are at the top of the hour. I can leave the call on. I need to run to another meeting, but I can certainly leave the call on if you wanted to continue the discussion.
I have to drop soon as well, but I think actioning remote board access and sort of nominating some boards for things that we would like to try and adapt the BSP from is worth considering. I think we might even be able to put some effort into that just in the name of fleshing out these problems. The board farm problem would benefit many people to solve. So seems like, yeah.
Yeah, getting a list of
just like the BSP, we wouldn't expect it to be we're not going to magically get a standard remote management plug overnight, but we can start to flesh out the problem space just like we can with BSPs. So.
Mm-hmm. Okay. Cool. It's an excellent question, and I think we should continue this discussion on the mailing list, and I will set up some, well, as any of us can set up some pages on the wiki to start fleshing out these ideas, both for the BSP and for remote access. The other items that were on the calendar, the main one was the future meeting schedule. Since there was no clear winner, I'm going to maybe propose that we start doing multiple meetings going forward, but I will go ahead and write this up for the mailing list and address it so we don't have to go over here today. So anyway, I will leave the call on, and I'm going to run off, and I appreciate everybody's participation. I think it's been a really interesting meeting. It's exactly the kinds of discussions we want to have. So.
Yeah, I'm going to have to bail too. Not that it's a great loss for anybody, but I wanted to hear what everybody else had to say.
Perhaps we should gavel the meeting this time.
Okay, yeah. Well, let's go ahead.
We'll have office. The informal meeting is in another 2 weeks.
Yes, we'll have an informal meeting in 2 weeks. We'll see you all there, I hope.
That's good.
Bye, everybody. Thanks a lot.
Bye-bye.
Take care.
Thank you all. Bye-bye.